There we go. All right. And the last thing I need is Zerno, so I can actually work on it as if it's on paper. And of course, Zerno has to open in a different window. Okay, open over here. Let's move it over here. There we go. All right. So let me open the document first. Okay. And I'll just pick one of them. 1199 is what we're looking for.
Did you have a conception that the last question would be the hardest?
No. I thought the carry look ahead was going to be the hardest one.
That was challenging too.
Yeah, that was probably the hardest for me.
For you? Okay.
And then the second after that was number 6. It was like those two where I was kind of, back and forth with those.
Yeah, I actually saved both of those for the last two, and then I had to switch back and forth because I'm running out of time.
Yeah.
Okay. All right, so we'll look at question 1 first. Question 1 is probably one of the easier ones, not the easiest, because the base conversions, probably are the easiest, because those are the ones where, okay, here's the fixed, process, right? They're just step, like that. This one, to a certain extent, is like that too, except the only change is instead of giving you all the t bits, I give you all the q bits. But it's equivalent. It is the same because once you know the result of an exclusive OR and you know one of the values to get to that result, you know what the other one is going to be. So I can pre-fill all the t bits just right away. Okay, so that's what I'll do now is to pre-fill. 0 exclusive of 0 is 0. 0 exclusive of 0 is 0. 1 exclusive of 0. Oops, got it wrong. 1 exclusive of with 1 is a 0. 0 exclusive of with 1 is a 1. 1 exclusive of 0 is a 1. Is that okay? All right. So now we can go back and try to figure out the x and y. So we have one extra carry bit, which is this guy over here. It's a 0. So you just have to end up with you need to think of a subtraction that ends with a 0, and it has no borrow. Well, there are 2 to choose from, right? 1 minus 1 or 0 minus 0. Doesn't matter which one you choose. They're both acceptable as correct answers. Okay, so I'm just going to pick 0, 0 here. Okay, and the next column is kind of the same. This borrow here means that I cannot have any borrow, but this 0 here means that these two have to be the same anyway, so I don't have to worry about that. Okay. Now we have a little bit of a different issue because this one is a 0, which means I do not have a borrow from the column before, but I need a 1 here. So the only subtraction that gives you a result of 1 but a borrow of 0 is 1 minus 0. So this time I do not have a choice. 1 minus 0 is the only choice for this case. Okay, so we look at this particular borrow, but it's already accounted for with this borrow here. Okay, so now what I'm really looking for is a subtraction that gives me a 0 as a result. Well, once again, we can have 0, 0, or 1, 1. Whenever I have a choice, I just choose 0, 0. But you don't have to. Okay, do we have any questions up to this point? Okay. And then this one as a borrow, means there has to be a borrow from the previous column. This doesn't give me a borrow of 1. Okay, so there's no choice in this case but to specify 0 minus 1 in this case. So that's the entire thing. Do we have any questions about number 1? Okay, it is pretty much the same as the practice test because once you know one of the 2 rows, Q versus T, you can work out the other one as long as I give you the difference. Okay. All right, so let's move on to question number 2. Question number 2 should be one of the easiest, of the entire test, because the form of the question is changed just slightly. Instead of giving you a mixed fraction, I now want you to specify a base 10 number with decimal point. Now that is possible because I'm using base 5. Okay, and base 5 is closely related to base 10. Okay, so it's actually pretty easy to write numbers in base 5 or convert those into base 10. Okay, so the number is 133.21 in base 5. So what I'm going to do, which is not necessarily what you do, but this is how I would do it. Okay, 100 plus 30. No, these are all base 5, so I haven't done any conversion yet. Okay, and once I have this, I would convert this to 1 times 5 to the power of 2, 3 times 5 to the power of 1, and this is just 3, but if you want to say 3 times 5 to the power of 0, that's fine. This one is 2 times 5 to the power of negative 1, and the last one is 1 times 5 to the power of negative 2. Do we have any questions about this part? Okay, so now I can do the actual conversion. Okay, so now we get 125, we have 15, we have 3 here. Okay, so now we move on to the negative powers of 5. What is 5 to the power of negative 1? It's 1 over 5, but 1 over 5 is also known as what in decimal places? 0.2. So we have 2 times 0.2, so that will give us a 0.4 in base 10. What about the next one? What is 5 to the power of negative 2? What does that look like as a decimal number? 0.04, right? And we have one of those. So this is one, this is just 0.04. So once you add up all of these, we have 40, 43 altogether. And then we have 0.44, after the decimal point. Is that okay? So the process is about the same as the question, the same question in the practice test. It's just that 1 over 5 is easily written as a decimal number, and 1 over 25 is also easily written as a decimal number, as opposed to 1 over 3. That's kind of ugly as a decimal number. So in that case, it makes more sense to use a mixed fraction. But in this case, it looks nice and it all works out. Are we good so far? Yes? Okay, moving on. Question number 3, which is exactly the reverse. So this one I cannot even change. I didn't even change the the representation, because if I want to change the representation, I have to choose a base that relates to 10. Okay, I just used 5 in the previous question, and I don't really have another one that's easy to work with. So I just choose to use a mixed fraction again. So the question is really asking you to write the value of 25 and 4/9 in this case as a sum of powers of 3 multiplied by some quantities, each one. Okay, so let's go ahead and get started here. Okay, so I have 25 and 4/9. Okay, and the first power of 3 that I'm concerned about is 3 to the power of 2, which is 9. How many 9s do we have in 25 and something? We've got 2 of those, so we say 2 times 9. And because my arithmetic is really bad, I just work on this step by step. Okay, but now I can say this is 2 times 100 in base 3. Do we have any questions about why the quantity of 9 is written as 100 in base 3? Because it is 3 to the power of 2. Okay, so when 3 is the base, and you have that base to the power of 2, it is 1 followed by the number of zeros is the same as the power. Okay, so let's focus on the 7. What is the next power of 3 that we need to use? We just use 3 to the power of 2, so the next one is 3 to the power of 1, which is just 3, right? So how many 3's do we have in 7? 2, okay? So we have 2 times 3, and the leftover is 1. Okay, there we go. So this is 200 in base 3, and this is 20 in base 3. What about 3 to the power of 0? That's 1. And how many ones do we have in 1? Right. So this is just 1 in base 3, and then we have the 4/9 left. So the next power of 3 is 3 to the power of -1, which we know as 1/3 or 1/3. So how many 1/3s do we have in 4/9? One of those. Okay, very good. So we have 2, 0, 0 in base 3, plus 2, 0 in base 3, plus 1 in base 3, plus 0.1 in base 3, because we have 1 of 0.1 in base 3. Is that okay? So what is left? What is left is 1/9, right? And as a result, okay, I know this is taking more space than it needs to. What is 1/9? 0.01 in base 3, because 1/9 is 3 to the power of -2, and as a result, it is 2 places to the right-hand side of the point. Is that okay? So you add up all of these, and it becomes 221.11 in base 3 in this case. So your question may be different. I think I have, I cannot remember how many variations of this question. Are we good with this one? Okay, all right, excellent. Question number 4. So question number 4 is one of the more difficult ones. I'm not sure, between this one and the last one, which one is more difficult. So the way you read this question, okay, so we need to bring up the notes first. Okay, so I'm going to bring up the notes from the class. And this is about binary addition. So we just go back to binary addition. And we know this is about carry look ahead. How do we know this is about carry look ahead?
Tells you.
Because it's in the question. Exactly. Okay, very good. Because right here in the question, we are considering the carry bit. This is K10. You're supposed to be in curly braces. Did anyone get this question in this particular way? The 10, with the 0 not in subscript? No?
I had 7. It might have been just the second you did.
Okay. Okay, I was. Okay, yours is 9. I think some people, no. You might have 4, but I think some people might have a 10. Anyway, it's supposed to be subscript in 10, okay? The 10 is supposed to be in subscript. Okay, so we want to use carry look ahead technique. So that means, in the notes, we're looking at section 6. So the thing about section 6 is the last portion of it is the summary. Okay, the last portion of it is, okay, this is how we generate K of something. Okay, so in this particular question, we are concerned about K10, right? So we want n plus 1 to be 10. Okay, so if n plus 1 is 10, what is n?
9.
N would be 9. Very good. Okay, so now we can just substitute all the n's with 9. Okay, so this becomes 9, this becomes 9, and so on. But the question is specifically asking about a conjunction term that has exactly 4 things in it, right? So now the question is, well, how do we find that one? You look at this side first and go like, well, does that look like it's going to have exactly 4 terms when n is what? 9. No, because when n is 9, this alone has exactly 10 terms. Plus this one, there are 11 terms in that conjunction. That doesn't meet the requirement. Yes?
It's just hard to read that. I ultimately never used that, even when we were just with
Okay.
us, because it's hard to read. I just don't know how to read that.
Okay, you look at each one as a loop, basically.
Right.
Yep.
Yeah, I understand that.
Yep.
Then how it actually works out, I couldn't tell you.
Okay, but you can use other ways to kind of derive it,
I
right?
did, yes,
Yeah.
yeah.
So as long as you use other ways to derive it, that's fine. But I'm just explaining, because I can read this. So I'm explaining how I solve this, by looking at this expression here. So I know this one is out of the question. Now, what about this big V thing? The big V thing has a whole bunch of terms, and each one is a conjunction. Okay. So I look at this and go like, well, do they have varying lengths, of those terms? The answer is yes. Okay, because I is going from 0 to n. But this inner loop is making use of I. So as I increases, the number of terms generated by this conjunction is going to be fewer and fewer. Does that make sense? Okay, because I is going to go from 0, where this thing is still pretty big, but as I goes closer and closer to n, this is going to get smaller and smaller. So what I need to do now is to say, there's a conjunction between the gi and this term here. So gi accounts for one spot of the 4. In other words, I just need this term here to generate 3 items. Is that making any sense? Okay, I know n is 9, right? If n is 9, without looking at the I plus 1 here, what is the range of j so that I have exactly 3 terms from this smaller conjunction? So 9 is 1, 8 is the other one, and 7 is the last one. Does it make sense? So I need j to go from 7 to 9. Is that okay? That will give me exactly 3 terms. Right? So if j, almost. So if j has to start from 7, what is I plus 1? I need I plus 1 to be 7. So I is 6. Very good. So that means that locks down this I here. So it will be G6, P7, P8, P9. That would be the conjunction term of 4 items for K10.
Yeah, I lucked out because I got K4 and I just did it. I just basically copied everything from K1 to K3 and extrapolated that out for the next ones and then
Okay.
circled the terms that were
I think next time I'll choose some really insanely large numbers, like, 100 something. So the variations will be going like between 100 and 106 or something like that. It'll be impossible to figure it out by expansion. You have to use the pattern to do it.
Well, I wrote it out. I didn't expand them. I didn't do like
Yeah.
What K.
You figure out the pattern.
I figured out the pattern.
You figure out the pattern and you say, okay, if it's K3, it looks like this. If it's K4, it looks like this. So, and then you extrapolate from that. It is okay, because I'm not asking for a proof. So in that case, you can just kind of like, I noticed this particular pattern, and it is consistent with K3, K4, possibly K5, and then you just go like, okay, so extrapolating this, for K10 is going to look like this. So I would take that as a valid argument because I did not ask for a formal proof. But I was kind of more or less expecting people to use this expression and just kind of reverse engineer the whole thing. No. Okay.
I as well found this very confusing, and I know that we did go over it in class, but I think it was just very quick, and it would take a long time for it to sink in, and I didn't spend the time. So.
Okay. All right. So we got number 5 here. Step by step derive the base 10 signed value represented by the following 6-bit binary number, blah, 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 blah. Okay. So with this one, I was expecting people to use a equation that is in binary comparison. Okay, interestingly, it's not in signed number discussion, but it's in binary comparison. But in binary comparison, I give you guys a v, function. It's basically a sigma minus, in this case, x n minus 1 times 2 to the power of n minus 1, where n is the number of bits in the number. That is the equation that I expect people to plug in and just go like, okay, plug in that equation. This becomes 0 plus 2 plus 4 plus 0 plus 0 minus 1 times 2 to the power of 5, which is 32. So you have 6 minus 32, which is negative 26. So that's one way to do it. The other way to do it is to notice that this is a negative value because the sign bit is a 1. So it's negative, but the question is, but how negative is it? It's not negative 6 because you don't just chop off the sign bit and look at the other part as the magnitude, right? You have to apply 2's complement. So if you choose to look at this and go like, okay, the sign bit is a 1, I just need to figure out how negative it is, then you have to apply 2's complement to find out what is the negation, the arithmetic negation of this particular number. That will give you the magnitude of how far to the left-hand side of the number line. Yep.
These numbers are different than our test numbers.
There are some variations of that, yes.
So you're stressing out.
Yeah, me too.
Yes, I can tell you how many variations there are, because I think all the questions have the same, not counting the most significant bit. So all the most significant bits are ones. Okay, so there are basically 5 choose 2 number of variations, which is 5 factorial divided by 2 factorial times 3 factorial.
Yeah, I was like freaking out when you're.
You just do that in my head.
Well, I teach cisp310, so I know that.
Wait, what's 440?
440 is discrete structure. It's basically a math class where we talk about discrete math, which is a branch of math that is more applicable to computer science than, say, calculus or numerical analysis or even linear algebra. Yep. So there are variations of this question. Yeah.
So for number 4,
Uh-huh.
I just said, because since it's a carry look-ahead adder, ki plus 1 is defined by ki, which is, ki is defined by what defines ki, since you don't explicitly say ki. So can you just say, for k10, the conjunction term is the same as k3, p2, p1, p0, and k0, because it's also defined by k3.
No, because after you expand it, it wouldn't be like that, right? Because if you look at K3, okay, so let's look at K3. So if you look at K3, it looks like it has P1, P0, K0, which is coming from K2. But once you multiply and distribute it, it becomes K0, P0, P1, and P2. So when we refer to carry look ahead, we're looking at this particular form of a carry, not the derivation leading to it.
Okay, but isn't that the same thing?
Isn't what the same thing?
What you look at before? I mean, they're the same. You get the same outcome.
Okay, when I refer to carry look ahead, this is the outcome that I'm referring to, not that.
Oh, okay.
That is just a step leading to the actual outcome that I want.
Gotcha.
Yep. Because the point of carry look ahead is we do not want any dependency, and we want to minimize the number of gates. So if you look at this version versus this version, the last row versus the second last row, the number of gates required would be different. The level would be different. If you look at this one, we require 1 extra level of gates. Because once you have this done, you still have to AND that with P2. So that is 1 extra level of gate compared to the last form, which only has a bunch of ANDs, but then we just OR all of the ANDs and we're done. Is that okay? So remember, the objective of carry log ahead is to reduce the number of latency to get to the answer. Is that okay? All right. All right, moving on to, okay, we just got this done. And number 6, okay. So I did not phrase question number 6 the way that I really wanted to. As a result, there are 2 possible answers. Okay, which is good for you guys, because if you give me one or the other, it will be considered as 100% correct answers. So let's go ahead and work out this one, okay? So this particular one has y being 0, 0, 1, 0, 0, 1 in base 2. X is unknown. This is a subtraction. This is another subtraction. We have Q, T, and D. All right. And this is all we know. But we also know one thing. We are setting the overflow flag, right? So if we're setting the overflow flag, only knowing this much, can I tell what the most significant bit of X should be and what the most significant bit of D should be?
Yes. Yeah, X should be a 1, D should be a 0.
This should be a 1,
Yeah.
and that should be a 0.
Yeah.
Right. Okay.
Yeah.
Okay.
The overflow flag.
Yep. Because the overflow flag has 2 conjunctions, and one conjunction cannot be true just because the most significant bit of y is already a 0. So it has to be the other conjunction, but the other conjunction requires the most significant bit of x or the minuend to be a 1, and the most significant bit of the difference to be a 0. So we can now lock down these bits. Okay? But once we lock down these bits, we can actually reverse and work out all of the other bits. So let's see how we can work out all of the other bits. All right, so knowing this is a 1, can you see my hovering pointer thing? Okay, so given this is a 1 and this is a 0, we know that this has to be a 1. Okay, there's no other way because Q is the exclusive OR between X and Y. But knowing this is a 1 and this is a 0, I also have no choice to put a 1 here. But this one is going to say, okay, there is a borrow from a previous column. The borrow cannot be coming from this particular subtraction. It has to come from this subtraction. In other words, I have no choice but to put down 0, 1 over there. But that means that also helps to lock down this to be a 0. Okay? 0 minus 1 is 1. That portion is not really important for this discussion, but I might as well just work out the entire thing. All right, so now we have this borrow, and this time, we can, there are two ways to do it, okay? Because we can put a 1 here, ending up with a 0 here, and then we can put a 1 here, or we can put a 0 here already, and in other words, I have a choice, okay? We do have a choice to put this either a 1 or a 0. So I'll put down 0 or 1 first, and then we'll think about which one should we use. Yes? So okay, so barely this time is defined, with okay, if you just add 1 to X and you perform the subtraction, it would not overflow, or the other way around. So it can go in either direction. Okay. So we'll go in one direction first and see what happens, and then we'll go in the other direction. Is that good? Okay. So this time let's just go for 1 first. Okay. So whenever we have a choice, we go for the larger one. Okay. So we have 1 minus 1, which is a 0, which forces this to be a 1 in order to come up with this borrow here. So this in return requires, well, this has to be a 0, so that we end up with a 0 here. And then this has to be a 1 in order to end up with a borrow over here. So 0 minus 1 is a 1. Because this is a 1, we also have no choice but to make this a 0. 0 minus 0 is a 0. And this one has to be a 1 in order to generate a borrow over here. Okay. And this is also a 1, which means I also want to make, now this time I don't have a choice. This one has to be a 0 because we know the least significant bit is a 0 for the carry or the borrow. So we have no choice to put a 1 over here. It becomes a 1 here, and it becomes a 1 here. So this is one answer. Okay. Now what if we took the different route? Okay. The different route starts here. Okay, this is where we can take a different route. So we can end up with 1 followed by all zeros. That's the other answer. So now the question is, which one or do they both satisfy the requirement of being quote unquote barely?
First one does.
The first one for sure does. Okay, this one for sure does, because if you just add 1 to it and you end up with 1 0 1 0 0 1, and then you subtract 0 0 1 0 0 1, it is quite obvious that we just end up with this, right? And there's no overflow. There's no overflow because it does not meet one of the overflow patterns. The overflow pattern is 1 0 0 or 0 1 1. This is not meeting any one of those two requirements to have an overflow. So this is not overflowing. It's not overflowing because I just added 1 to the X. So it meets the requirement. What about the other one? Okay, so you look at this pattern here and you say, well, adding 1 is not going to help. What about subtracting 1? Because in the question I say you can also subtract 1 from X. If the result of subtracting 1 from X does not lead to an overflow, then you can also write that as an answer. So if you subtract 1 from this guy, then the X minus with a subscript is going to be 0 1 1 1 1 1. Let's see. Yep. Okay. So let's carry out that subtraction. 0 1 1 1 1 1 minus our original, which is 0 0 1 0 0 1. And it is quite obvious that we don't have an overflow because there's no borrow in this case. So we end up with 0, 1, 0, 1, 1, 0, okay? And there's no overflow. There's no overflow because 0, 0, 0 does not fit into the two patterns to have an overflow. Is that okay? So as it turns out, because of the way I phrased the question, both of these, I have to accept both as correct answers, like 100% correct. Yep.
When you subtract 1 from 1, 0, 0, 0, 0, 0, that overflows that number.
Yeah, but the overflow has to do with this subtraction or this subtraction. I try to make it very clear. It is not this subtraction or this addition that I'm concerned about. It is this particular subtraction or this subtraction. If one of those two gives you a no overflow situation, then that x is okay. Can be the answer. So as it turns out, in this case, both of these are acceptable as 100% correct answers because of the way I define barely in the question. Which in a way is favorable to you because if you give me one or the other, it's 100% correct. It is exclusive or, yes. If someone says, give me both of these as answers, then it's like, okay, but you have to choose one or the other, or explain to me why both of them are correct answers. So it's not inherently exclusive or, but most people would just give me one answer. Did you give me both?
I gave you one.
Okay.
I did it because I saw it was 9,
Mm-hmm.
and then to make something overflow, it would have to be.
You can use that as an argument as well. Yes. So you can look at this as 9.
It has to be 30 negative. It has
Yep.
to be negative 33.
Yep. So you can argue that way as well. You basically start with the most negative value that you can represent using 6 bits, and then you just say, oh, okay, if this is beyond a certain point, the subtraction or the difference is going to exceed what we can represent, and then you can argue with that argument as well. I'm just looking at all the bits as individual bits. Are there any questions about the 6 questions for today? No. So all this silence is prompting me to remind you guys, in this class, 37.5% is a C, and then a B is 62.5%, and an A is 87.5%.
Why did
Yes.
you make it 87.5 for A? What was the reason?
Because it is 7/8. Okay, so the idea that I use, okay, so you're asking about why I choose those specific percentages. Okay, so I'll write it out like this: A, B, C, D, F. Okay, so we know that A is a 4.0 GPA, 3.0, 2.0, 1.0, and 0, right? In terms of GPA. Okay, so if I convert these into percentages, okay, then F is 0%, A is 100%, C is 50%, D is 25%, and B is 75%, right? But these are centers of each grade. So I have to say, okay, but what is the range, of a particular grade? Well, I just choose the midpoints. Guess where the midpoint is between A and B? 87.5%, yes. So that's why 87.5% or more is an A. And then between these two is 62.5%. So that's why that is the range of B. And this is 37.5%. And this is the range for a C. And this is the range for a D, which is 12.5% and up. And lower than 12.5% is an F. I think most people would agree that is an F.
Yeah.
Yes.
So is that scale how you're going to be grading the test?
Yes, that is exactly the scale of how I will be grading each question of the test. So for each question, I will break it down into several criteria, okay? And then for each criterion, I'm going to assign, numerical values based on this range, based on this proportion. So that's why at the end of the semester, because everything is graded based on this particular scale, at the end of the semester, I take the average, and this is how I break the percentages down to letter grades.
Um,
Yep.
when will we know what we got on the test?
Well, the that's that's a very good question because part of it is now because you know how you answer the question. So the grading scheme is an A is pretty easy. Okay, what qualifies an A is a perfect answer. Okay, it's but there are multiple perfect answers. Like in all of these questions or most of these questions, there are different ways to derive the same answer. Okay, and they're all good. Okay, as long as I understand how you get to the answer and the method that you use is logically sound, I go like, okay, this is not how I would do it, but this is correct, 100%, not a problem. Okay, so what a B typically is a simple mistake. Okay, somebody messed up an addition. Okay,
Reading the problem wrong.
that is a little bit different. Okay, it depends on how it manifests. Okay, that one is a little bit different.
There was, it said sign value, and I
Yeah.
ignored that.
Oh, okay.
So I used that one as a 32 or whatever it was.
I see. Okay, so typically a B is something that is obvious to me that is a very simple mistake, but the person still demonstrates that the main concept is understood and that person knows how to apply the concept. Okay, a C is basically telling me that person is barely understanding the concept, but the application is mostly wrong. Okay, so maybe the person quoted the right equation or the right expression from my notes. Okay, but the application is like, I have no idea why this is following that. Okay, that would be a C. A D is some kind of vague mentioning of concepts, that is involved, showing me that that person has some but insufficient understanding of the knowledge, let alone the application. So, but there is some kind of indication. It's not like nothing. It's just not enough to convince me that that person really understands the concept. And then the F is like not. I cannot find any evidence that that person understands what we're dealing with. Ultimately, the C, where this line is, okay, this line right here, where that line is an evaluation of whether that person is ready to move on to another class that requires knowledge of this class. Because that's basically how we work with prerequisites, right? A letter's grade of C or better in order to fulfill the requirement of another class. That's basically the bottom line is, do I look at an answer and I say, okay, I think this person is ready for the next class. Maybe marginally, but ready. Yeah, in a class like this, with me grading, a C is really the worst possible grade, I think, okay? And some people may say, but the D or an F is even worse. Not really, okay? Because with a D or an F, at the end of a semester, you can take the class again. I'm not saying you, I'm just saying the person who's getting a D or an F can just take the class again. And, I don't really judge people. I judge answers, but I don't judge people, okay? So someone who's getting a D or an F can have a variety of reasons why that is the case. Okay, my teaching style does not match that person's learning style. Okay, that's a pretty common reason. Okay, that person may be sick for more than a week. Missing some classes as a result. There can be many, many other reasons. Okay, I don't really care. Well, okay, I shouldn't say I don't really care, but it is not. I do not judge that person. Okay, but the idea is that person can take the class again and be prepared for whatever class that is following this one. In here, there's no class following the cisp310. The cisp310 is not prerequisite to any other class in a community college. This is the highest level I can teach at a community college. But when you move on to a 4-year university, they might have classes like computer architecture or something along that line that is based on what you learn in this class. So the question is, well, if I give you a C, does that mean that you are ready to move on and take that class? So I have to answer that question in my mind in order to go like, which grade should I give? But a C is bad because it means it's barely meeting the requirement, which also means that person may have difficulty when that person is taking the next class. So to me, that is not good. Okay, a B is basically saying, yeah, for the most part you get it, but you might have made some, careless mistakes in the tests or forgetting to turn in some of the homework assignments, but it's not usually a big deal. Okay, so that's how I look at the letter grades of a class. What do you think? Yep.
Would it be possible to look at the tests now, just like, not like bring them out of the room or something, or just, can we just see the answers that we put on the test, on our test?
Oh,
Just to,
I would say no, because that would involve redistributing the test to all of you and recollecting it. So I'm not gonna do that. But what I will do is okay. So for those of you who are taking my classes the first time, I make photocopies of every single page that you turn in. So after that, after I make all the photocopies digitally, you can have the test back. I mean, I really have no intention to keep your test. So you just have to remind me to bring the test back and pass it back to you in class. There will be no marking on the paper itself. All the grading is going to be through Canvas. So once I make digital copies of your test, I'm just going to Google Drive and look at the copy on one side, and then look at Canvas on the other side to do all the grading. So I will return the test to you. It might take. Okay, so in terms of paperwork, actual paperwork, I have to destaple each and every single one, get it through the scanner, name the file of the PDF, and then restaple each one, and then upload all the files to Google Drive. So it is a little bit tedious, to finish the whole process, even before I can actually grade anything. There's a lot of paper handling. We'll just call it paper handling. From the Design Hub. No, I cannot because of FERPA. FERPA is a student privacy thing. So nobody other than me is supposed to know about your grade. So I cannot have another student to handle anything that relates to grades. Maybe a robot at some point. Yep. But then if a robot is smart enough to do that, the robot is smart enough to replace me too.
Right. Well, you got a new teacher then.
You have what's his name? What is the robot in Borderlands 2 and 3?
Claptrap?
Yep. You have Claptrap, wheeling into the classroom like, we'll talk about blah 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 today. I think they did a really good job with the animation and the voicing of all of the characters in Borderlands. Okay, not related to class. So are there any other questions about the test? No? Okay, so this is 20% of your grade. Okay, so for those of you who are super concerned about your actual grade out of the class, you can think of it this way. You can afford to lose 12.5% altogether over the entire semester and still get an A. So I'm assuming you turn in all of the lab. So the labs, I think most of you are getting 100%, if not close to 100%. Because most of the labs are okay. Try as many times as you want. Just get it right before the due date, which is a week from the assignment. So that's about 20% that you should not lose too many points over. The test itself, is the kind of stuff that you can lose points over. But I'll give you a tiny little secret, okay? Sometimes, there's no guarantee, but sometimes I will drop the lowest scoring question. So if there are 6 questions, I will say, okay, drop the lowest one. So only the highest scoring 5 questions, it will count for the grade. It is not always fair, okay? Because I can give you a scenario where, it hurts one person, but it doesn't hurt the other person, okay? So let's say one person answers only 5 questions and the last question was not answered at all. So you have basically 100%, 100%, 100%, 100%, 100%, and then 0%. So to that person, dropping the lowest score is now just turning the whole thing into 100%, right? Because if I only count 5 questions and all 5 questions are 100%, that person is now getting 100% in this exam. But another person may be spending time on all 6 questions and then getting, let me count here, getting 5/6 of the scores, but for each question. So dropping the lowest scoring question is not going to help that person because that person is getting the same score for every single question, adding up to 5/6 of the possible score. So now one person is getting a lower score because of the adjustment, and the other person is getting a higher score because of the adjustment. So I have to kind of keep that in mind and go like, okay, so what do we do with that, right? I can choose to just change the divider. Then it will help both because both will just become 100%. But I have not figured out how to do that in Canvas yet. It's like super duper easy in Moodle. You just change the base point, and you're done. But in Canvas, I think it's a little bit harder. So I have to figure out how to do that in Canvas. So but it all depends on the distribution of the class. I look at the distribution, and most of the time, after all the adjustments, I get about half the class getting A's and B's. So to me, that is about the right, adjustment point. So here comes the next question. If the entire class did really, really well, would I change the grading curve so that 1/2 of the class gets C's and D's and the other half gets A and B's? The answer is no. This is not a UC. I do not do that. But once you move on to a UC, especially one of those more prestigious ones, you might see professors doing that. So you might end up with a whole class of really smart people. They're all performing at their peak, and the whole class got 90-something%. Okay? Some professors hold the view of A's and A, B, C, D, F are relative, at least A's and B's. Okay, C, D, F, maybe more absolute, but A and B's are absolute. So they will change the grading curve to end up with a certain percentage of A's and a certain percentage of B's. Keep that, huh?
That's intense.
Yes, it has a very interesting effect on students. Because when you have a grading scheme like that, students tend not to help out each other anymore. Yeah. Whereas a more absolute scale like the one that I do, I mean, if you help your friends, hey, you're not going to change your grade. I mean, even if after you help your friend ends up with a higher score than you, it's not lowering yours. Okay, it doesn't change yours. But if it is a more competitive, curve thing, then people will be they're more, let's just say more. I wasn't about to say that. That was not the word in my head.
They'll find the smartest kid. Hey, what's your phone number? I'm going to call you at 4 a.m. in the morning of the exam and just wake you up.
There were stories of sabotage.
Yeah.
There were stories of sabotage even at Dave. Okay, I shouldn't say even, but at Davis. Okay, people would break into lockers, of other teams, in a particular class and sabotage the projects. Yeah, that to me is totally uncalled for. It's one thing to tell the other person, it's like, I'm not going to help you, right? Okay, but it's another thing to actively try to sabotage somebody else's project. All right. So any other questions before we end today's lab? Nope. Okay. Was the test hard or? Nope. Not too hard, right? Challenging? Okay, challenging is good.
I think I did better on it than I anticipated. I thought that it was going to be absolutely insane.
So you have heard a lot of horror stories.
No, it wasn't even that. It was going over the first exam.
I see.
Was very intimidating to me. But actually, after going through that and then watching the video again and doing it, actually this morning I watched the video of you going through the last exam and doing it myself along with you. And then I brought that exam as my notes. So that cleared a lot up. Actually, it made the questions a lot more approachable.
Okay.
So, yeah, I think that's actually a really good thing that you do.
All right. Well, you spend the time to prepare, so that's good. All righty. I'll see you guys next Monday. Have a nice weekend.
All right, you as well.
Yep. Thank you. Mm-hmm.
If we got the wrong answer, but the method that we used was like the method.
Hold on.